Okay, thank you. Well, now it's easier when make presentation of other authors. It is joint work of big team about WMO guidance on measuring, modeling, and monitoring of canopy layer urban heat island. Key messages and applications, what we would like to stress, and here see what the leading authors and the full team is even much bigger, and I think it's more than 45 authors and also reviewers were involved in this study, and the request for preparing of such guidance was done by World Meteorological Congress, and we invited scientists around the world who are expert in this area. So Heinke, Toulouse, and Shiguang with myself coordinating, and also Alberto, Matthias, Valéry, Shiguang, Chao, Matthias, and Iain Stewart were leading chapter leaders, and many contributing authors you can see here, and also reviewers. So the structure of the guidance includes, from one side, overview of processes relevant to canopy layer urban heat island. In chapter 2, analyze urban scales and definition. One of the reasons actually for this guidance, first of all, of course, importance, especially with climate change and urban development. But from other sides, a misinterpretation of urban heat island in different studies, and it is in some papers, yesterday also discussed that it is used in different things by term of urban heat island. So this we try to make some analysis and formulate how better to follow and answer on main questions. And second group of sections, it's applications where practically canopy layer urban heat island information is needed. And first of all, of course, focusing on different services. And the main group for methods to determine urban heat island, and of course starting from characterization and also observation requirements, modeling, and longer-term monitoring. And finally, the main group, chapter 8, is focusing on how possible to mitigate urban heat island effects. And also, just for clarification, we start from this processes influencing canopy layer urban heat island, and how it's different with, for example, subsurface urban heat island, surface heat island, and boundary layer urban heat island. Of course, it is important to consider, but in this guidance, the main focus was done on canopy layer, which is the most important for study and applications. And of course, first of all, processes influencing canopy layer urban heat island analyze, including city forms and geographical setting, and meteorological influences, main parameters, and also surface influence. Here, of course, you can find in section 2.5 more information, and I'll go into details. And for processes influencing, of course, meteorological conditions include usually clear sky, high solar radiation, and light winds. And here you can see quite classical picture with dynamic. But what is important, also in many studies, interpretation is used not correctly, but it is extremely important. For example, mitigation measures. The canopy layer urban heat island intensity at maximum is usually in evening and night time. And of course, it is important to consider. And also other important contribution about evaporation effects. And in previous Goldberstein study, was nicely demonstrated that it is extremely important and affect very differently on surface and canopy layer urban heat islands. And this is extremely important to use. And also it leads to different mechanisms of heat islands, urban heat islands for surface, for boundary layer, and for canopy layer. Here you can see a nice simulation of such differences for surface and a kind of idealized simulation done by Alberto Martelli. And for our purposes, we need information about urban heat islands and analyze and provide kind of recommendations for different type of use. First of all, for heat stress information for services, for health impact, and also for air pollutants concentration, for air quality systems, and for energy provision services, and for energy use impact, and for urban greening services, and finally for multi-hazard urban warning system. And of course for longer-term analysis of urban developments and within climate change. And here just say what, because it's mentioned here, what important to build specific metrics, for example, like minimum, maximum temperature, daily mean, seasonal mean, annual, and special pattern of metrics. So, and for different applications, it was analyzed and suggested what kind of metrics better to use. And as a part of analysis for measurement and determination of canopy layer, urban heat island, chapter 5 is focusing. And here, of course, many issues are very, very important. First of all, choosing site where to put sensors and corresponding footprint, characterizing, analyze, and give recommendation for that. And also for neighborhoods, of course, some typical conditions should be for choice of measurement instruments and their location. And for modeling, of course, there are many models and also analysis of applicability. Different models done in the guidance, including statistical models, which are simple and quickly realized, but required a lot of data and long-term measurements, intensive measurements. So they are have some limited applicability. Another type, obstacle solved models, largely simulation, direct simulations, and Reynolds average approaches are used quite often, but it is nicely resolving processes within street canyons and urban canopy, but relatively expensive. And of course, numerical weather prediction and climate models are now urbanized and more and more used for such purposes. Of course, with many advantages, there is also a disadvantage for specific issues for studies resolving processes in canopy layers and in street canyons. Of course, limitation is clear. And also, what is important for different scales, parameterization of urban canopy processes different. And for example, here we suggest a kind of hierarchy of different parameterization which can be used for different purposes. And application, of course, also use it for different systems, and, from early warning and up to longer term analysis. And finally, monitoring is also very important for longer term analysis of urban heat island dynamic, and also integrating observation and modeling capabilities. And finally, mitigation and adaptation efforts is extremely important. First of all, physical changes to urban environment include surface materials, blue and green infrastructure, built and street forms. But what is important, what signal from such measures could be different for positive and negative, so it is very important to analyze effectiveness of such measures. So this I will not read, but you can see the main conclusions what we just briefly touched and this guidance, first of all, of course, oriented for meteorological and hydrological services, but also could be used for different agencies and stakeholders, and also for scientists. So, main conclusions what we would like to stress for users is mentioned here. Thank you.
Thank you very much. So we have time for one or two questions.
Thank you. Simon, this is really much required by the community. So thank you to see doing this and seeing this. Was there any discussion or any supplement available on the low-cost sensors and remote sensing in the context of what is being done, and guidance about use or misuse of that?
Yeah, good question. And we had a lot of discussion in this working group. First of all, because the guide focusing on canopy layer, surface characteristics which are used by satellite data are not always completely useful. So we mentioned that, of course, but there's some comments for that. Concerning low-cost sensors, again, it is a separate topic which required a lot of analysis and applicability conclusions. And WMO is working with this focus, and we have special tasks and also reports with recommendation where it could be used and for what kind of purposes. Even more for urban meteorological observation, we have this what's called WMO guide for observation, and chapter 9, which is urban observation, was written by Tim Oak long time ago, and now time to rewrite and build a new version, because previously Tim focusing mostly on urban climate application. And now we have to care about full spectrum for high impact weather, for nowcasting and hydrology, and for air quality, etc. So now it's requirements very different. And also now we start learning how to treat such data measurements, because NWP models are not simulated observation within urban canopy. But a lot of data we have, and we need to learn how to use them. So it's next step. And I'm also glad what Lena Jarvi and Matthias wrote are involved in this group who will work further with such guide for urban observation.
Thank you.
That's basically a way to end the session. Thank you very much to our co-chair, to all the authors for their great presentation. And a little bit turbulent, but we got on track again. And we're on our way to end the discussion that we started.